Well, thank you guys so much for inviting me to speak here today. This is really exciting for me too. So I'll just give a little bit of an introduction about who I am. So as you just heard, I'm the pollinator ecologist at the ESF Restoration Science Center. And so my work there takes a wide variety of forms, everything from academic research to pollinator surveys, identifying bees under the microscope, helping to manage campus grounds, growing native plants in our greenhouses, and a lot of different kinds of outreach as well. While my work focuses on pollinators, there's a lot of intersection with plants and with other wildlife like birds. And my education is in conservation biology more generally, so that covers a lot of habitats and species in our region. I also really enjoy using photography to bring the public closer to the world of insects. So I hope you like the photos that you'll see in this presentation of some of the cool species in our area. So a brief overview of what I'm going to cover in the next 45 or so minutes. So we'll start with some life history and ecology of some of our native pollinators, go into a little deeper into the world of our more specialized pollinators, then start with the basics on how we want to make pollinator habitat in gardens in our yards, and then how we can tweak that to support some of our rarer or more specialized species. Then some considerations on developing plant lists or designing those gardens, and then go over some resources. You might have seen over at the table, there is a page of resources that I'll reference a couple of times in here. So any of the links that I put up are repeated on there, so you don't need to try and jot everything down really quickly. So let's start off by meeting our pollinators. Most of us might think we know these little guys pretty well. These are bees. But did you know that there are nearly 450 different kinds of bees in New York State? And in the US as a whole, there are around 3,600 different species. Now, this doesn't include honeybees because honeybees are not native to North America. And so this is really just a tiny slice of the vast diversity of colors and forms that our native bees can take. And each one has unique relationships with our native plants. Right next to those are our native wasps, which are just as diverse in their colors and forms as bees are. There's over 1,600 different kinds of pollinating wasps in North America, and that includes both social and solitary species. The only major difference between bees and wasps is what they feed their young. So plant protein in the case of bees, and animal protein in the case of wasps. To me, their lives are infinitely fascinating, and I think they're just as worthy of our care and admiration in our gardens as their bee cousins. Then we have butterflies and moths, known as Lepidoptera, and there's nearly 13,000 species in North America. Around 95% of those are moths. Both butterflies and moths can be pollinators, including our nocturnal species like our sphinx moths, although in general, butterflies and moths aren't considered particularly efficient pollinators. But that being said, they have another really important role in our ecosystems as food for a lot of other organisms. So even though pollination might be secondary, this is a really important group to conserve. Now, probably one of the most overlooked groups of pollinators is flies, even though arguably they contribute more to our crops than butterflies or moths do. So there's over 1,600 different kinds of pollinating flies in North America, primarily in a family we call flower flies or hoverflies. And we also have another family, the bee flies, which you can see an example in the top right here. Now, you can obviously see that a lot of these mimic bees and wasps, even though they're completely harmless. And some of them are really specific. So this one in the top left here is the bald-faced hornet fly. So I think that's a pretty convincing mimic. So to me, these flower flies are some of the most charming and charismatic little visitors to our gardens. Last but certainly not least are beetles, and we have around 250 different kinds of pollinating beetles in North America. Again, you can see how many of these are mimicking bees and wasps. So most of these are in the longhorn beetle family, but we also have scarab beetles, soldier beetles, and many others that frequent flowers. The larvae of those longhorn beetles are also important as decomposers because they're living in dead and dying wood. Now, I wouldn't want to forget our one vertebrate pollinator, the ruby-throated hummingbird. We won't talk too much about them in this talk, but ecologically, it's filling a niche that is similar to our day-flying sphinx moths. So for this presentation, I'm going to focus on these two groups here, the bees and the Lepidoptera. All pollinators matter, and I'm the first to say that I'd be the president of the WASP fan club if there was one. But these groups are useful to talk about for a couple of reasons. Firstly, we have good data on them. So we have a better sense from most species what their ranges are, their habitat associations, and whether they're in decline. And they're also tied to plants, both as larvae and adults. So they tend to be limited more by the availability of certain plants than other groups, which might need certain habitat features or certain kinds of prey. And of course, as gardeners, plants are the realm that we work in best and we can have the biggest impact on. So when we provide for the more narrow needs of these groups, by proxy, we'll make habitat for many of the others as well. So let's dive a little bit into the life history of our native bees. Sadly, most of what we've been taught about bees so far is related to honeybees, but honeybees are really unique in the bee world. They have what's called advanced eusociality, which is where they live in these large multi-year colonies with a division of labor like workers and queens. Thing is, almost no other bees live like that. Out of the 450 or so species in our state, the only native eusocial bees are bumblebees and some sweat bees. That being said, that kind of social behavior they have is a lot simpler. So their colonies are much, much smaller and they're annual, which means that at the end of the year, all of the workers die off and next year's new queens are the only members that survive. Whereas honeybees, all of the workers survive and feed off that honey that they've stored up. So ecologically, that makes a really big difference in how they exist in their habitats. We also have a handful of weakly social bees, which is where a mother and her immediate offspring might share a nest for a little while. But in general, the vast majority of our native bees are completely solitary, so around 3/4 of them. And that means that it's just a single female who is going to mate, go out to flowers to collect pollen, and excavate a nest. She divides that nest into different chambers or cells, rolls the pollen into balls, lays an egg on each pollen ball, and then closes up the nest. That is the last she will ever see of her future offspring. Those eggs are going to hatch into larvae. The larvae eat the pollen provisions and then usually overwinter before continuing to develop, pupate, and become an adult the next year. So really that is the life cycle of an average native bee. Now, around 70% of our bees are ground nesters, and their nests are just the width of a pencil and anywhere from a few inches to several feet deep. But again, since most of these are solitary, this is just a single bee to a nest. Some bees, like our mining bees, like this one, tend to form aggregations, which is where many individuals of the same species all make their nests really close to each other. But since they're solitary, they don't interact in any way. So they tend to do this when there's really good nesting habitat, like a big patch of bare soil, a south-facing hillside, or a pile of sand. A lot of our bees are actually obligate sand nesters, so the substrate really does make a difference in what bees are going to nest there. Now, these solitary ground nesters are only active for a few weeks of the year. So once they have finished building their nests and they close them up, pretty much all evidence they were ever there disappears until that same time next year. We also have bees that nest above ground. So some are using dead plant stems. They're looking for stems that will persist at least a full year, and ones that are either hollow or have a really soft pith that they can dig out themselves. Others will use cavities like in wood or logs, and some use man-made structures like any sort of nooks and crannies between our front steps or a wooden fence that we have, or even a bee hotel. Each species usually has a distinct preference for where it likes to nest. If you've ever seen what looks like these semicircular holes cut out of leaves, that is from a leaf cutter bee. And she cuts those leaves, rolls them up, and uses that to divide up the different chambers in her cavity nest. Now, lastly, we have bees that don't make any nest at all, and these are the cuckoo bees or the kleptoparasites. Some of my favorite bees. So these lay their eggs in another bee's nest, and their larvae eat the pollen that was meant for the host larva. This isn't what most people are probably thinking of when they imagine pollinators, but this is actually a really common and successful strategy for bees. So it's evolved multiple times independently, and there's more kinds of cuckoo bees in the world than there are social bees that make hives. So again, our picture of what an average bee is slowly starting to shift here. We even have parasitic bumblebees that take over the nests of other kinds of bumblebees. So it can get really complex. And so these cuckoos tend to be host specific. So one kind of cuckoo goes after one kind of host bee. And that can make them pretty closely tied to the welfare of their hosts. So in that way, they are almost bioindicators. To have lots of cuckoo bees around, you need healthy, diverse populations of other kinds of bees. So now let's talk about how pollinators are choosing and using floral resources. So they rely on all sorts of cues to help tell them what flowers have suitable food for themselves or their offspring. And a big factor is their tongue length. So if you've never seen a bee tongue, this sweat bee is sticking hers out here at the camera. It's that long elbowed apparatus they have. So wasps, flies, beetles, these tend to have really short tongues, whereas butterflies, moths, and hummingbirds have really long tongues. Bees vary quite a lot across the spectrum, from very short to very long. So as gardeners, we know that flowers come in all sorts of different shapes, sizes, structures, and tongue length is partly what limits which insects can get in and access that nectar. So when we see a field like this that is dominated by flowers that are shallow and flat, things in the aster family, the carrot family, maybe shrubs like dogwoods or viburnums, that's where we're going to see a lot of short-tongued pollinators, small bees, wasps, flies, beetles. They really like these kinds of flowers. When you have flowers like this, it's more larger insects, longer tongues that can pry those open and get at the nectar inside. Now, of course, there's exceptions to everything. Short-tongued bees might nectar rob, which is where they actually cut a hole with their mandibles in the base of the flower and steal the nectar without getting inside. And long-tongued bees might also frequently visit these shallow flowers when it's convenient. But in general, they're going to prefer the flowers they're best adapted to. So bumblebees are a great example of this. Tongue length varies a lot within bumblebees, and you can actually see the species separate out by their flower preferences. You can predict where you're going to find them. So these two bumblebees here are pretty similar looking, but they're actually two different species, and both of these are in decline. So one of these is short-tongued and one is long-tongued. We can be smart about targeting the flowers that a specific species might need if we're trying to garden or manage habitat for that one that's at risk. So for long-tongued bumblebees, we might want to plant mints, penstemons, bee balms, or legumes, those deep flowers. And for short-tongued bumblebees, we might plant goldenrods, asters, roses, coneflowers, shallow flowers. Ultimately, in a habitat, we want a good mix of flower structures and shapes to provide for all of these pollinators. Now, things like tongue length or flower color, these matter when it comes to attracting those adult pollinators. But for most pollinators, adults are eating something different than their young, and the adults have way more choices. So the limiting factor for most pollinators is food for their offspring. And this mining bee here is a great example to illustrate this concept. So right now she is foraging on elderberry, and that's what all that white pollen is on her face. But if you look at her back legs, you can see that it's covered in gold or orange pollen there. So that means that she actually got that from a different flower, and that is the pollen she's taking back to the nest. She's not collecting any pollen from this elderberry. She's actually just there to drink nectar, which fuels herself. So when we plant for pollinators, we need to focus on the food they need for their young. That's how we actually increase pollinator populations. So this brings us to specialization, which is kind of the main theme of this talk here. And it's one of the most important concepts when we think about making pollinator habitat. So let's start with bees. Now we get that bees don't visit all flowers for many different reasons, but when it comes to gathering pollen for their young, bees can be generalists or specialists. So let's use this example here of a sunflower, and let's say this is in our gardens. So here we can see some common eastern bumblebees, Bombus impatiens. We all have these in our yards. They are the quintessential bumblebee. So right now they are foraging on this sunflower. And the thing is, they could easily go to many other kinds of flowers that they like and gather pollen from those too. They are one of the most generalist bees that we have. They actually like having many different choices because different flowers have different nutrients in their pollen. So if we didn't plant sunflowers again next year in our garden, we would almost certainly see this bee regardless. It has many other choices. Here's another bee that you might find on that same sunflower. This is a kind of longhorn bee, one that specializes on sunflowers and a few related plants. So if you didn't plant this sunflower again next year, you probably would not see this bee anymore. It evolved to feed its young the pollen from sunflowers. And even though it could go to other flowers and it might for nectar, it won't gather pollen from them. So luckily, this species has a broad enough host range that it will use these ornamental annual sunflowers that we plant in our gardens, which aren't native to the Northeast. But here is one last sunflower bee. So this is the sunflower mining bee. Also a specialist on sunflower, but it's a lot rarer because it doesn't use those annual ornamental sunflowers. It only uses our native perennial sunflowers, which are not common in the wild here and not many people plant them. So specialists can target plants at the family level, the genus level, or even the species level. And the more narrow that association is, the more those specialists could be at risk if habitat destruction or invasive species wipes out a patch of its host plant. So here in the Northeast, around a fifth of our bees are pollen specialists. Their entire lives revolve around their host. Adults are only active for a short window of time each year when their host plant is blooming. We also have many bees that are tied to certain habitats along with certain plants. So this bee in the bottom right here, the goldenrod cellophane bee, this is a great example. It's pretty much restricted to deep sand deposits that have goldenrod. You tend to find it near the coast. But if you keep going out to the actual coast, like on the beach, the dunes, it's actually replaced by a really closely related species, the beach dune cellophane bee. Also a goldenrod specialist, but the substrate it prefers, the texture of the sand is different. So something that specific can make the difference between one species and another. These relationships can be some of the most complex and fascinating in the pollinator world. And they make a big difference on how we need to protect and manage for these species. Here's just a few more examples of specialists in our area. The hairy-banded mining bee, which is another one that relies on goldenrod, probably one of the most common specialists that you can see. If you just go out in August on some goldenrod, you can probably find these. The pickerelweed short-faced bee, which only visits pickerelweed in our emergent marshes. And the blueberry cellophane bee, which needs both blueberries and sandy areas for nesting. So when we're only taught about honeybees, we are really missing this true diversity of our native pollinators and those intricate relationships that they've co-evolved with our native plants. Now, the concept of specialist bees might be new for a lot of people, but we tend to be a little bit more familiar with it when it comes to butterflies and moths. So this adult monarch, it's happy to drink nectar from ornamental garden plants, but it's limited a lot more by what its caterpillar eats. So that monarch caterpillar can digest the defensive compounds in milkweed, but nothing else. So if we want to conserve monarchs, we need to provide the host plant for the caterpillar. Oh, that's my fault there, sorry. It'll shut off. That's fine. Right, so if we want to protect these chubby little guys, we need to provide their host plant. There are much more options for the adults for nectar sources. So specialists are a lot more prevalent in Lepidoptera, the butterflies and moths, than they are in bees. The majority of caterpillars are specialists, at least at family level for plants. So for pollinator gardens to be effective, we need to include the host plants, not just these showy flowers that can attract the adults. That could give us a false impression that we're being successful when we have all these butterflies around, but there's no place for them to actually reproduce and make the next generation. Of course, this has huge ripple effects across ecosystems. You're probably familiar with this because, you know, you've seen Doug Tallamy speak probably before, but caterpillars are the primary food source for songbirds and their babies. And we're seeing huge declines in a lot of our native birds, in part linked to the declines of flying insects. So we desperately need to increase the biomass, the living volume of caterpillars in our suburban neighborhoods. Not just because they'll go on to be butterflies and moths, but because they are a pillar of our food webs. So here's the thing about specialists. They occupy a very narrow ecological niche. That makes them bound to limited resources. And that could leave them at risk because they need that specific resource to be stable over time and space. If something happens to their host plant, either on a small scale, like a new housing development, or a large scale like climate change, shifting a bloom period earlier, that could be bad news for specialists. They don't have the same flexibility that generalists do. Of course, this isn't to say that generalists aren't also at risk. Habitat destruction, pesticide use, diseases, these things threaten all of our pollinators. But specialists can be the most susceptible to the loss of plant biodiversity, and they're more likely to disappear without any of us noticing. So what's good is that we can support them just through changes we make at a local level. So now let's shift into how we can manage our properties to benefit pollinators. And I'll start off with the foundational principles that we try to follow when we build pollinator habitat. So the first thing you might already be familiar with is bloom turnover. And this is when we want different plants blooming sequentially from early spring through fall, so there's no gap in resources. And we want to use a variety of flower structures and colors. So having a turnover of shallow flowers and a turnover of deep flowers. Ideally, we want at least 3 things blooming at any given time. And so why is bloom turnover so important? Well, firstly, we have different communities of pollinators that are active in spring, summer, and fall. These communities can turn over as quickly as every 2 weeks. So as these new species emerge, they need resources there immediately during that short window that they're active. It's also critical for our native social bees like bumblebees. These are needing to support a whole colony across an entire season, and so they need a steady and diverse supply of pollen and nectar. In general, they need a much larger quantity of resources than a single solitary bee would. So these early spring and fall resources tend to be lacking in suburban landscapes. So we can be conscious about where these gaps might exist in our neighborhoods. Apart from food, pollinators like bees and wasps need some place to nest. So ground nesters are looking for areas of exposed and uncompacted bare soil that faces the sun. Cavity nesters might be using coarse woody debris like logs and snags, or those persistent pithy stems. It's really easy for us to provide those stems just by not cutting back our plants down to the ground when we tidy up. So what we recommend is cutting plants in the spring rather than in the fall, and to cut them to a height of around 8 to 12 inches above the ground. So you don't have to look at those very long. They're going to be covered up by new growth quickly, but bees or wasps are going to nest in there, and it takes them an entire year to develop and emerge again at that same time. So basically, the best thing to do is once you cut them that first time, just don't touch them ever again. Don't cut them a second time, don't do anything. They will disappear, you'll stop thinking about them, but the bees are going to be in there and they need to overwinter in there and be able to emerge in a full year, over a full year's time. What's great is that you can then take that cut material and fashion them into a stick bundle, and those can provide habitat for the species that prefer horizontal cavities rather than vertical ones. Now, if you want to promote bumblebees, that's a little bit more difficult just because they are nesting in old rodent burrows. So therefore, that's not something we can directly make habitat or create artificially. But the best thing to do there is just to create habitat that is suitable for things like voles and shrews and small mammals like that. Now, the last thing I definitely want to talk about here is leaf litter. So leaf litter is one of the most important parts of a pollinator habitat, just as much as flowers. So many of our caterpillars overwinter in the leaf litter, as well as some adult butterflies like the mourning cloaks, which we'll probably start seeing any week now. And as well, our queen bumblebees. So the one bumblebee that survives the colony each year, she's going to be nesting, overwintering right below that leaf litter too. So without leaf litter as protection, they would not survive the cold temperatures or they'd be eaten by predators. We spend a lot of time thinking about giving pollinators flowers in the warm season, but they just as much need to be able to survive the rest of the year and complete their life cycle. Otherwise, it doesn't matter how many flowers we give them. So that leaf litter is also great for our gardens. It's the best mulch. It's going to break down, give nutrients back to the soil. It suppresses weeds, and it's good insulation for your plants too. So if we shred or burn our leaves, we are going to be killing all of the insects that are inside, and we're depriving the rest of a safe place to overwinter. So what we recommend is just raking your leaves to key parts of your yard, like beneath your trees, into your garden beds, along your fence margins, places that might not look unsightly, but they're right where those insects need them. The other thing you can do is reduce the size of your lawn. So I probably don't need to tell gardeners that lawn is not great habitat. And the fertilizers and pesticides we use to keep them looking perfect are what go on to harm our pollinators, birds, and our water supply. So there's a lot of options for what you could do with a patch of lawn that maybe you don't get much use out of or isn't growing very well. The first thing is to just convert it to a meadow. These meadows cost a lot less to maintain in the long run, and they're much more dynamic. So there's always something new to look at, season to season and year to year. ESF has a Lawn to Meadows program where we can provide information and assistance to homeowners in the Finger Lakes region, primarily around Skaneateles Lake, but probably outwards as well. For anyone who wants to pursue this option, we actually have a little handbook on our website for Central New York homeowners. So if you're interested in this sort of thing, I encourage you to check out our webpage, and that is on the resource list as well. Another great option is to use a lawn replacement. So this is a native ground cover that can take some foot traffic. There are many great options for our region, and I put asterisks next to ones that I feel are particularly good as caterpillar host plants. Personally, wild strawberry is one of my favorites. Obviously, it has these wonderful white flowers. Bees of all kinds love it. Caterpillars, it's one of the best caterpillar host plants, and it makes fruit that we can eat. So it's a win-win. But any of these would be much, much better than just an area of turf grass.
Can you tell us what they are from top to bottom?
Sure. So yeah, wild strawberry, poverty oak grass, which is like a little curly grass that only gets a few inches tall. Wild violets, green and gold, which has yellow flowers. Many kinds of sedges like Pennsylvania sedge, wild ginger, bearberry, white wood aster, which is this one down on the bottom, purple lovegrass, my favorite grass. That's the one that is like pink or purple, hazy looking grass that you see on the roadsides in the summertime. Creeping phlox or moss phlox, many kinds of ferns and moss gardens. Yes.
I'm at the pictures.
Oh, I'm so sorry. Yes. Wild strawberry, the native violets, that's probably Sororia, and the whitewood ester. But now I've heard them all, yes. So that's just a few of the basic principles, and all of these things will take you a long way, even if you can only do part of that. But what I'd like to think of these are templates to me that we can tweak to support more species, different species, and also maybe some of these rarer specialists, just by incorporating their host plants. So these here, you might recognize a lot of these plants. This is what I think of as the standard toolkit. So these are on a lot of these pollinator recommended plant lists for our region. I'm not here to tell you these are the wrong plants. I have almost all of these in my garden. They are great for supporting a wide variety of pollinators. They have a good diversity of those different flower structures and colors. But there are trade-offs here. So some of these not native to New York or even to the Northeast. And that means they've lost some of the interactions they have in their native range with different insects. And a lot of them skew towards blooming in the midsummer. So we might be missing those spring and fall windows. This is exponentially better than having lawn or having just hostas and daylilies. And what's great is that we can more easily find these at nurseries nowadays. So it's more accessible to people. So these are great plants, but we can expand outwards a lot from this. So let's look at maybe some of our other options here. So the first avenue you could take is to focus on keystone species. And this is where a lot of Doug Talamy's work comes in. So these are plants that are common on our landscape, and they have a disproportionately large amount of relationships with native insects. So these are really what's forming the backbone of our food web, and they're critical to producing that amount of caterpillars that birds need. So you can see the full list of these keystone woody plants here. This is from Doug Tallamy's book, Bringing Nature Home. As you can see, these are woody plants here. So there are keystone wildflowers under the herbaceous section. I put a few there. And that is from the work of Desiree Narango and Doug Tallamy as well. But here's something that's, to me, interesting to note. So if we go down all the way to the bottom of this list, we see chestnuts with around 125 caterpillars. That's not shabby at all. But that at the bottom of this list is about the same as the top of the list for wildflowers. So goldenrods and asters have around 100 to 125 caterpillars. So it's really woody plants that are pulling a lot of the weight here in producing caterpillars. And we need more of these in our landscape. Then we have basically the equivalent for specialist bees. So these are the plants that host the greatest number of specialist bee species in the Northeast. And up at the top, we have goldenrods, willows, blueberries, and asters. All of those are on the Keystone list for caterpillars as well. So there's a lot of overlap. You can see the full list, and this is on your handout, so no need to jot this down. The full list of specialist bees and their host plants at this website by Jared Fowler from Xerxes. So those are really the top performers. They're the most bang for our buck. They are what keep our food webs running, and we should absolutely be planting these keystone species. But I think it's important to not totally forget all of the other many plants that aren't as well known or maybe not as productive in that sense. So taking these two habitats for a second, this meadow on the left, objectively, it's going to have more bees in it than this bog on the right. But does that mean we should drain all of our bogs and convert them into meadows? Obviously not, right? Those bogs are providing their own ecosystem services. They are hosting rare plants, and they're offering floral resources at a different time of year than meadows. They might have fewer bees, but the bees they do have are unique. Personally, I think cranberry bees and the Parnassia mining bee are worth keeping around in their own right. So pollinators need every kind of habitat on our landscape, and they need all kinds of plants too. Here's just a few examples. Our native violets again. They host the violet mining bee, and they're the only host plant for all of our fritillary butterflies. The spring beauty, Claytonia, one of our woodland ephemerals, host for the spring beauty mining bee. Our native loosestrifes, like this one, this is world loosestrife, host for 3 species of rare oil bees, which collected floral oils. These bees have their own cuckoo bee that was thought to have gone extinct for decades because nobody could find it. And it's been rediscovered just within the last couple of decades. And the humble jewelweed, which is a classic streamside annual with those exploding seed pods we all love, host plant for the white striped black moth. Most of us have probably seen this little moth flittering about in the undergrowth, but maybe not realize if they're because of this plant, or for whatever reason, one that we rarely cultivate. So really the list can go on and on and on. There are very few native plants that don't host some kind of caterpillar, and the ones that host specialist bees like these range all across the board. So when we are looking to make a bloom turnover, we need those spring, summer, and fall flowers. We can have these in mind and incorporate host plants into that seasonal palette. At the same time, you know, we're gardeners, we do this because we love plants too. So each native plant has a unique story and a unique beauty that we can appreciate. And we should want to have all these unique plants in our gardens. Now, it's worth reiterating that pollinator habitat is much more than just wildflowers. We need rocks and logs and leaf litter, and we need plants that aren't pollinated by insects, from oak trees to grasses to ferns. Without ferns, we wouldn't have our pink shaded fern moth like you can see on the left here. And so many of our skipper butterflies, like this Zabulon skipper who's laying their eggs, need native bunch grasses. Our grass carrying wasps also rely on those bunch grasses to get the material for their nests. All those plants help form the physical structure, the niches and layers of our ecosystems, and they support each other above ground structurally and below ground with their roots and mycorrhizae. So quality pollinator habitat is really just a functioning ecosystem. And the more we can approximate that in our urban landscapes, the more species we'll support. So what this means is that you have a lot of different choices when it comes to how you could use your property to benefit pollinators. There's all these different angles that you could approach from, and none of them are any better than any other. But before you start planting anything, you should have a clear goal in mind and the steps that you want to take to get there. So in any ecosystem, most of the ecosystem services, like pollination, and most of the biomass of insects are going to come from generalists, especially a handful of the most common generalists, like those common eastern bumblebees. So if you want to make a lot of caterpillars for birds or support at-risk bumblebee species, or maybe improve the pollination of an orchard you have, you might want to steer towards those keystone species. On the other hand, most of our biodiversity is found in specialists. They're more likely to be rare or declining, and they're less often supported by our traditional plantings. A lot of those specialists do use keystone species as a host, but not always, right? A lot of them don't. And while most of the time generalists will benefit from the actions we take to protect specialists, that also isn't always true. There can be trade-offs. So an obscure but super cool plant might host 2 or 3 kinds of caterpillars, whereas a keystone plant might host 100 in the same space. So the thing is, if, as we lose more natural habitat, if nobody decides to grow that obscure plant with only 3 caterpillars, those 3 caterpillars and the moths that come from them might eventually blink out and disappear. Now, I wanted to give just one cool example from my yard here. I think, we can absolutely plant for specific species that we want to see in our yard. We're allowed to have favorites. And personally, I think it's great that we do because, someone's love for a species is what makes us go out of our way to protect them. So here, this is from my yard in Syracuse. This is skullcap, hoary skullcap. I planted this 5 years ago because I really wanted to see a skullcap skeletonizer moth. And I don't blame you if you haven't heard of it. It's about that big, but I just thought it was really cool. And so that was 5 years ago that I put that in. And finally, just last year, one night in August or so, on my front door, I finally saw one of these guys. I know, they're really tiny, but if you look at them up close, they have metallic silver scales on them, and they're really cool. So that's really, the things that make it worthwhile for me, because I could be sure that that came from my garden. There's no other skullcap around. And so this is really a tangible way that we can make a difference for our local ecosystems. These are things that are rewarding and they'll come back to us. So if you want to put in evening primrose just to get evening primrose moths, or squashes to get squash bees, that is perfectly fine. If you want red admiral butterflies or question mark butterflies, you need stinging nettle. So when you're weeding next time, think about, think critically about what you want to take out and what might be worth keeping. At the end of the day, a love of nature is why we're here doing this. So I wish this was my garden, it's not. As I'm sure you guys all know, there's a lot that goes into choosing plants for your garden and how to design that garden. So what your goals end up being might depend on something like the size of your property. You might want to plant keystone species if your space is small. That's a way to maximize the contribution of your yard, especially if there's not a lot of other habitat around. On the other hand, if you have more space to work with, you can have a greater abundance, a greater diversity of plants. Another aspect to consider here is how much of a host plant a specialist might need. So a chestnut bee might need a single chestnut tree, but a violet bee might need hundreds of violets for a single nest. So a small yard might not have space to support certain specialists, and that is perfectly fine. The other aspect is your growing conditions. So most of us here in the greater Syracuse area probably don't have the right soil to support sand nesting bees or plants that need acidic soils like our ericaceous shrubs, things like blueberries, rhododendrons, laurels, things like that. It's a lot easier to choose plants that fit your conditions rather than to change the conditions to fit the plants. So just make the most with what you've got. That will probably be the best benefit to our local ecosystems anyway. The same thing goes for soil moisture, sun, deer pressure, anything that you'd normally be thinking about. Now, of course, I don't have time to go through details of design considerations. That is a whole other presentation. And if you want to get into the nitty-gritty of that, I highly recommend any talk or book by Larry Wiener. He is a master in ecological landscaping. But I have provided on some of these handout resources. Many of the books and PDFs and websites have designs like this that can get you started. And you can see here, one of the main things we look at is clumping plants. So we want to make patches of many, the same species of plant in clumps. And that is how pollinators visually hone in on those resources. So that is sort of a basic thing that we can work with, but the specifics are up to your property. There could be aesthetic considerations, practical ones, and artistic ones as well. Most of you are probably aware, hopefully, that you guys have a great resource at your fingertips with this Wild One shopping guide that gets put out every year. So this is a great way to find out what nurseries are selling some of these more obscure plants or the host plants every year. And they actually do list specialist feed. There's a column for that. So there's that you can use that should be coming out for this year anytime soon. On our webpage, the ESF B Campus webpage, we also have a list compiled of native nurseries in Central New York, as well as some online sources as well. So one last element to consider is if you want to make food with your yard. This is absolutely compatible with pollinator habitat, as long as you don't use pesticides. So we have all sorts of fruits and vegetables whose flowers support bees, from strawberries to blackberries to apples. And we also have specialists on some of our crops. So squashes, tomatillos, cranberries, strawberries, and blueberries, most of all. One that we don't often think of is ground cherries. So that one is the native relative of tomatillos. It came in on its own in my garden. They're tasty, edible, and they have 3 different specialist bees. 2 of them are pretty rare. So that is a great one to just sort of hard to find in nurseries, but if it comes in on its own, that's a great one to keep. Beyond conventional crops, we have all sorts of wild fruits like beach plums, pawpaws, elderberries that host all kinds of bees. And many of our nut-producing plants that are great for caterpillars like hickories, hazelnuts, chestnuts. So you can absolutely make a food garden that benefits you and pollinators at the same time. Now, of course, nobody can make habitat for all species on our property, as much as that frustrates me personally, that I would love to just have every species in my garden. But we are limited by growing conditions, our space, and what species probably exist in our local area to even be able to come find our gardens. So that's perfectly fine, right? We can expect that. But what's great is that our yards are part of the larger landscape and they all contribute something to it. So if you can provide just one element that is missing from your neighborhood, like early spring flowers or nesting habitat, then you have helped our local ecosystems. What we want to promote is connectivity. So getting more of these tiny little habitat patches to combine with each other and with natural areas to form corridors. And these corridors can run through cities, through agriculture, and they allow pollinators to move to where they need to be. And these corridors are greater than the sum of their parts. They can support more species than each patch alone. So what is the roadmap for making pollinator habitat in your yard? We can boil this down or summarize this to just a handful of things. First is just figure out what you already have in your yard and what you don't. And this includes your neighbor's yards as well, because that's all within the foraging range of the pollinators. Determine your growing conditions, which you might already know if you're a gardener. And then figure out a goal for your yard, what you want to accomplish, and work with those basic principles to come up with a plant list and a tentative design. We want to avoid cultivars, even cultivars of native plants if we can, because those tend to be less nutritious or less palatable to our pollinators. Start small. You should test the waters to see if the plants like the conditions you're putting them in. They might not always want to stay right where you plant them. Yes. I feel like the garden's nodding yes. It's better to start with clumps of just a few species than to dive in with 20 different things and hope they all work out perfectly, because they will not. That way you can, grow over time organically and adjust that design to where things have actually settled out to be. Lastly, we want to make sure that you document and celebrate your progress. So documenting what you find is really important for scientists to help be able to monitor and conserve our pollinators. Rare species do show up in gardens in cities all the time. I have rare bumblebees that show up in my yard in Syracuse. Don't know where they're coming from, but I'm happy they're there. So even though you might not be able to identify everything that comes to your garden, if you post it on one of these sites, experts like me who are on there, we will be able to. And that can be really important for us to track those records. So I highly recommend using a site like iNaturalist to log your observations. It's a great way to keep a species list for yourself, and you can find out what other people have seen in your area, which could give you a new goal on maybe a new plant you want to put in to try and get that species to come to your yard. You can also register your patch of habitat with many different projects like Doug Tallamy's Homegrown National Park, Monarch Watch, or Pollinator Pathway. These are all trying to create those corridors that run across our entire country. Ultimately, what we want is more native plants on the landscape and less turfgrass lawn. We want to keep common species common and keep rare species from toppling over the edge into extinction. These are equally important goals for our ecosystems. So there is so much biodiversity in central New York, and not very much of it is represented in our yards yet. So now you've seen that basic toolkit of pollinator favorites. That's one route you can take. There's the Keystone species route, and then there's the specialist host plant route. These are not mutually exclusive, and they probably are best used in combination with each other. We don't want everyone planting the exact same thing because inevitably some species will miss out if we just keep recommending the same plants over and over again. So this is a chance for us to be more creative with our gardens and more thoughtful about how our land connects to the larger landscape. To me, it's rewarding to foster biodiversity, and it's a way that we can make a difference in our communities that scales up to supporting ecosystems on a global scale. And it's something that's tangible. It will come back to us for us to enjoy as well. So if we learn, cherish, and steward our local flora and fauna, I think we will be in pretty good shape. So here is just some of these resources that I have on the handout, and I brought a few of the books to look at if you are welcome to flip through them. These are some books that are just really great that I own all of these for either learning more about native bees, learning some native plant suggestions, and also how to design those, with those different considerations. This is a copy of all of the links that are on the handout as well. These are all really great websites, either as seed sources, as sources of information about bees or plants, as well as the fact that a lot of these were made by my colleagues in the Northeast, some of the people that are at the forefront of researching our native pollinators. So you can spend hours just learning about stuff on here. It's really fascinating. So thank you guys for having me here today. This was super fun for me, and I hope you got something out of it. If you're interested in learning more about what we do at ESF, visit the Restoration Science Center webpage, as well as our Bee Campus webpage. And there's my email also up there. I'm happy to take any and all questions that you have. Yes.
Your opinion of mason bee houses?
Yes. So the question for the Zoom people, the question was, what do I think of mason bee houses, which are probably same thing as bee hotels is how they're generally marketed. So that is something of a dicey issue among pollinator researchers. They are good as a teaching tool. They're great to be able to observe bees up close. As a way to actually help pollinator populations, they don't really do anything. So the issues with bee hotels or mason bee houses, outside of ones that are used like commercially for agriculture, which are a different setup, the ones that you can buy in like Home Depot, their problems with them is that one, they're generally used by non-native species. So they're generally used by non-native bees. So the one that tends to use them a lot in our area is the horn-faced bee, Osmia cornifrons, which is a type of mason bee, but it's non-native. when I put a bee hotel up in my yard, that was 100% what used them. So they generally, and it will vary slightly depending on where you are, but most of the time they're going to be used by our non-native species. The second thing is that you need to very carefully take care of them and either bleach them or replace them every year. Otherwise, they will build up diseases and parasites very quickly. And if that's not done, it will do more harm than good for the bees that are living inside them. Ground nesting bees are used to living in aggregations that are in close proximity. Cavity nesting bees don't do that in the wild. So when we pack a bunch of these tubes next to each other, you are drawing in, that is like painting a target on there for parasites of many kinds, not just parasitic bees, but parasitic wasps, mites, diseases, viruses. So it can increase the disease load in there as well, more than you'd find in the wild. So in general, they're great to have in a yard as a way, for kids especially, to be able to see bees go in and out and learn how they make those nests. We don't use them as a conservation tool, and we generally just would prefer you make natural habitat with existing sticks that are in the wild. Yes.
Species that you can't get or difficult to get locally, would you recommend just not getting them and sticking with native local genotypes, or how do you feel about prairie moon and so on that have really diverse plants? But
Yeah. I think it depends on where you're using them and what the goal is. Obviously, we have sort of different standards, I guess, for restoring natural habitat versus in a garden. We want to get those local genotypes as much as possible for seeding an actual natural area. But when it comes to gardens, I like to give more flexibility, because what's the other option? Not having the native plants, so we don't want to sacrifice the good, for the best there. And so, yeah, it's great when we can, request of nurseries that they get more species, and that is happening every year. We are getting more and more from our local nurseries. The availability always is getting better. And what's great about the local ones is that it tends to be more local genotype. That's ideal. I think just because we don't have a local genotype or the availability of a species in general doesn't mean we absolutely shouldn't use it. I think that would give us a chance to look and say, is this species native to our county or our area? Is that why it's not available? It's because maybe we shouldn't be putting it in because it wouldn't belong here. But if it is one, we have so many native plants that are native to our county or native to the state that are just not cultivated yet. Most of them are not. So if there is a seed source online, like Wild Seed Project has a lot of them, Prairie Moon has some of them. If that is like the only way for you to get this interesting species that is native to our area and it's in a garden setting, I wouldn't limit that to our local genotype. But if it's a larger planting or a naturalized planting, ideally we would be able to find at least a genotype for the general region. So we use Ernst seed a lot, which is a lot of Pennsylvania, New York ecotype, and we can consider climate change in that as well. So Pennsylvania ecotypes might work better in the future in New York. So there's some flexibility with that. Ultimately, things like Prairie Moon, which might be like, more Great Lakes, Wisconsin ecotype type of things. I think that's on a case-by-case basis. If you can get a more local seed source, that would be preferred. But if that's the only chance and you're putting it in your garden, I wouldn't say no to that.
Can we take a question from Zoom?
Sure. There's 30 messages.
I think she's gonna read it out and it'll come out here.
Okay.
Jill, can you read the question?
Absolutely. First, Molly, everybody's sending you lots of thank yous.
Oh, thank you.
The first question is there a recommended distance from the road, especially a busy big one, that pollinator plants should be planted?
Yeah, so the question was is there a minimum recommended distance from roads, especially big roads, that we should plant pollinator habitat? So for highways, yes, definitely. We want to at least 2 to 3 meters. So I mean, I would say at least 10 feet from the edge of a highway, because highways have a lot of issues in terms of like heavy metal runoff, salt runoff. And keeping a mowed border. So when it comes to large roads like highways and stuff, yeah, we do want to we do have a wide margin from the road. When it comes to like, there's a lot of recommendations for planting like the hill strips or the medians. If it's like next to a sidewalk, that is probably fine. Obviously, salt is an issue everywhere, and that will probably, we don't yet know all of the effects it might have on pollinators themselves, but we know it has effects on plants and how well the plants are gonna grow, and anyone who's tried to plant things on city roads or out on our campus and different things, a lot of the plants don't survive because there's that much salt getting run off into them. So if it's stuff like next to a sidewalk, I mean, people do plant those pretty close to the sidewalk there. I would say it's fine there. You're gonna have to watch to see if you're getting salt, runoff damage for those plants if they're not doing well. Yeah, medians are another sort of thing. The latest on the recommendations for medians is that it's probably not a good idea to pollinator habitat there at all. Just because there's a very high mortality rate for insects trying to cross roads. And all of the runoff that you're getting from large highways, like salts, like heavy metals, like pesticides or fertilizers, those go off right into the median. And it's not wide enough habitat to really be able to be free from those effects anywhere. So we can make a lot of great roadside habitat and sidewalk side habitat on less busy roads, but in big highways, the medians are probably best. Not saying we shouldn't have native plants there, but maybe not focus on trying to attract pollinators to those areas because the risks might outweigh the benefits in that sense. So it does differ. I think if you're trying to plant a sidewalk side, that is fine. You might want to choose plants that are more salt resistant or drought resistant, or there are certainly plants that are better suited for cities, more hardy adaptable ones. But pollinators should be fine as long as they're not having to cross busy roads, which can be a real issue for them. Yes.
Well, that brings up another question. Is ESF going to be involved in the medians once 81 is down?
Potentially, yes. We have had meetings with the DOT about it. So we may be involved with that, and we have brought up some of these recommendations with them. So hopefully that, I think highways are a really good opportunity to be making more pollinator habitat, or even just better habitat for anything by not mowing them as much and choosing smart plant choices. There are, rules in some states, about, having to choose native plants and native seed sources, for when you do these construction projects, but a lot of states don't have that. And the extent to which it is, actually implemented varies. So I think in general, if we can just start getting native grasses and native plants seeded in here instead of turf grass on the side of the road, I think that will benefit a lot of things. So yeah, there's a lot that can be done there, but it needs to be done thoughtfully to make sure that we're not actually exacerbating existing problems. Yes. Oh.
Yeah.
Okay.
Well,
Is there another Zoom question?
There is another Zoom question,
Okay.
and this is getting back to basics.
Yes.
What's the difference between nectar and pollen?
The question was, what is the difference between nectar and pollen? And I am not a plant biochemist here, but so nectar is going to be the sugary liquid food source that is powering adult pollinators to go about their daily business. It's an energy source for them. A lot of pollinators can only drink liquids. So that is really their main food source. Some like beetles and some wasps, they can't eat the pollen. Beetles will often come to eat the pollen. But nectar is generally the food source for the adults. And pollen is going to be the protein source. So it is primarily protein as well as many other antioxidant compounds, sometimes secondary plant metabolites, which are defensive compounds. And that's where kind of specialization comes from, is the ability of these insects to co-evolve over millions of years to digest the specific defensive compounds in certain pollen types. This is much more familiar with, when we think of caterpillars being able to digest certain leaves, but the same thing happens in pollen. So that's what leads to bees specializing on some pollen kinds. So the pollen, the protein is really what the larvae need to develop. And that, bees evolved from wasps. And so we started with, insect hunting wasps that then started using plant protein. So it's just a shift in protein type. So the pollen is the solid food stuff that the larvae are eating. And obviously it's the reproductive material for the flowers themselves that hopefully at the same time being transferred between flowers, whether the bee likes it or not. They're not doing it purposefully. The bees often try to get the pollen off of them. And if they're trying to collect that pollen, they groom it into specialized places on their body, hairs that they have, that then they remove it, they take it away. So when we think of pollination, it's actually more of an arms race rather than a cooperation much of the time. We certainly do have specialized co-evolutionary relationships that plants rely on certain pollinators. But also at the same time, when you have any sort of bee, especially a specialist bee, they are trying to remove the pollen rather than transfer it to another flower because they need that pollen. So the plants are adapting ways to trick the bee into getting pollen on their bodies that they can't get off. The bee is trying to evolve ways to more efficiently collect the pollen away from the flower. So it's an arms race that goes back. Hopefully that was a long answer to a short question. But yes.
Do you have any opinions or guidance on how to encourage municipalities, schools, parks departments to plant more native species?
We're gonna need to repeat that one.
Okay, so the question was, do I have any advice on encouraging municipalities, schools, businesses, towns to plant more native species and pollinator habitat? That could be a tough one. I don't have a lot of, I'm still young in my career. I don't have a ton of hands-on experience with it, but in general, I mean, a lot of it comes down to obviously not having the information, not even thinking about this. So providing knowledge and reasons why it's an easy and good thing to do. Sometimes there's a barrier in terms of, I don't know what plants I should plant. I don't know where I can get those plants. How much is it going to cost? How can we maintain it? Whereas the things that they're already doing most of the time with mowing turf grass every 2 weeks or pruning your hydrangeas and stuff, that is taking just as much, if not more time, energy, and money to maintain than a native planting would. So sort of laying out the advantages of doing this as something that's less cost and less effort for the business, for the town. That is one way to encourage that. When it comes to public spaces like schools or libraries, there's a lot of teaching opportunities. So getting the community involved, getting signage, getting opportunities for kids to get involved, making it a sensory garden, making it things that, this is something that benefits the entire community. We're not doing it just because it's good for the environment. It's something that will beautify a town. It's something that will connect people to the land. And it's something that, can bring people together to install or to maintain, or something that we can have programs around. It opens so many new doors. So I think just bringing that information as to the advantages of why ecologically it's important to do, why it is a cost-saving thing, and why it's great for outreach and education, great for kids. I think the main barrier is just not having the information and not knowing. That is the first step, and then helping people find out where they can acquire the plants, because that can be a real barrier, just not knowing what resources are in our area for that, which is why Wild Ones has been so great with compiling those nurseries and everything. It really makes that more accessible for people. So that's what I can recommend, at least right now. Yes. Yes.
In terms of local ecotype, on the native plant shopping guide, we indicate L or S, and
Yes.
the L indicates the nursery is collecting local seed. So it makes it a little easier to find that. Also, in terms of this last question, there is on our habitat garden, there is a whole section that shows what other communities have been doing. So I can show you that part. It's under ACT community, and there's a whole bunch of resources because a lot of communities are making progress in that. And I've tried to collect all those resources. So it's our habitat garden ACT community, and things are happening in different communities, allowing native plants and so on. So I've tried to collect that. So you might want to browse through that and see what they're doing.
Yeah, there's a lot of either grassroots movements or these like large scale citizen science projects like Pollinator Pathway, or what ESF is doing here is we're part of the Bee Campus USA program, which is through the Xerxes Society. That is specifically, there's Bee Campus and Bee City, and they are specifically trying to encourage municipalities and or campuses to sign up for this program, which involves creating native pollinator habitat. So that's something that any small group of interested people can go to their town planning board or environmental commission and propose this. And it's fairly straightforward to do. And it's a commitment, but it's one that really looks good, and you get signage and you can get, coverage for this in local news and just getting that word out to people. There are so many programs, and a lot of them provide small grants for assistance to get these things started as well. Xerxes will even send you like 200 free plants. So I mean, there's a lot of ways that we can get off the ground with these things. Yes.
As a resident of Clay, are you going to be involved in reviewing the wetlands problem at the Myclan project? ESF.
I can't speak for the rest of ESF. I don't work with that stuff specifically. That's not something that at least me or my immediate colleagues that I know of are part of, but I'm not involved with all of the direct water, fisheries, wetlands related stuff that is going on at ESF. So I really couldn't say.
Okay, except you're with the Restoration Science Center, right?
Yes, I'm with the Restoration Science Center.
And
So
aren't they gonna be legally required to restore wetland areas? I believe. Whatever wetlands they develop, they have a legal
okay.
requirement to compensate or restore.
The mitigation.
Yes.
I presume so.
Yeah.
That sounds right.
So
Yes.
you guys will be contacted.
Okay. No, hey, yeah, at the Restoration Science Center, so I work directly with Don Leopold, Sam Quinn, who runs our Lawns Meadows project, Michael Schumer, who does a lot of wetland and waterfowl related things. But there are many people at ESF, great faculty that will probably be more directly involved in that than I will, but sounds very interesting. And yeah, more wetlands mitigating things would be good. For all the wetland bees too, special wetland bees. So
See if there's any, ask Jill. Jill, are there any more questions on Zoom?
I actually have one for you, Molly, if you have time.
sure.
So I've been trying to create bee nesting strips for ground nesting bees.
Yeah.
And I've been following Evan Abronson's plan of mixing half sand, half soil,
Mhm.
and made 2 areas. They're both around 2 by 4 feet. So how do I tell if the bees are actually using it?
Repeat all that.
Yeah, so the question was, Jill is trying to make bee nesting strips, which are a way to attract ground nesting bees by basically like carving out a piece of ground and refill it, like removing all the vegetation and refilling it with a soil sand mixture. So I've never used those personally. They sound great. I work with Evan, so I'm sure he knows his stuff there. Basically, so you'll know that bees are using them firstly if you start to see nesting holes. They're going to be small, but maybe like a pencil width. And depending on what's using them, it might be a single hole, it might be a small aggregation with maybe a dozen or a couple dozen nests. You'll start to see more increased activity of bees near that area as they come and go hovering around the ground. And it all comes down to, I guess, luck, time of year. So most of those bees are only going to be active for a couple of weeks. So you got to catch them during their nest building phase. And once they are all plugged up, then it will look like there's nothing there. So I would start checking them in late April, early May. And if you just check them at least like on a weekly basis, then you should be able to catch something using them. We have a lot of bees that don't need huge patches of open soil. There are ones that will nest in turf or nest between landscaping stones. But if you provide that nice open patch, you will definitely get more and more different kinds of bees. So I can't imagine that they won't use that.
Okay, and someone actually just typed in a follow-up and asked, since there's not much sand around, what ground nesting bees are in central New York?
So the question was, since we don't have a lot of sand around here naturally, what ground nesting bees can we expect here? So as I mentioned at the very beginning, most of our bees are ground nesting. And so most of the bees that you are seeing out there in the wild are ones that are nesting in the ground. While we do have a lot that prefer sand, those are species that are generally going to be a little rarer in New York. So we don't have to worry about them anyway. Although that being said, when there are sand deposits, even from artificial means like construction work, when there's sand or gravel beds left over, bees that are rare regionally can come and find those. As work I've done over at Montezuma, where they have sand deposits there, we do have those sand obligate bees where we wouldn't otherwise expect them. So bees do have a way of finding habitat where it doesn't seem like they would be able to. That being said, you can expect all different kinds of mining bees, different types of sweat bees. Those are the primary diverse ground nesters that we have. But there are many kinds, and obviously bumblebees are going to be around under the ground as well. And yeah, I mean, I have many kinds of mining bees in my yard that are happy using this clay soil here. In general, I don't think we have many, if any, bees that prefer clay soil, but they will tolerate it. And they will, as long as it's uncompacted, so it hasn't been run over by cars or equipment very much, it's loose enough for them to actually dig into, then they will use it. They'll use soils in our garden beds. They will use soils in our yards as long as it's aerated. Right. Okay. Yes.
You know if there's any like coordinated effort or like database to kind of track like the priority, especially of like these specialist species that are like teetering on the edge of extinction? Like I'm assuming like black-eyed toucan, for example, those aren't anywhere near extinct. No, species that rely on those aren't really threatened. But what about these, you know, these ones that are like teetering on the edge of extinction? So we can kind of try and coordinate prioritizing certain species that are about to go.
Yeah, so there are certainly a lot of efforts in our region to try and compile what information we know about these rare species. So a lot of it is that we don't know a lot about them. They're very poorly studied because we don't find them very often. So in that way, it can actually be difficult to tell if they're declining. We don't have enough records to actually track them through time. So a large effort that's recently been completed was the Natural Heritage Program just finished their Empire State Native Pollinator Survey and put out their final report like last year, a couple years ago. And they do assign conservation ranks to a lot of these species, but a lot of them are still not enough data. So it's hard. We have an okay understanding of the plants that they need. We don't always have an understanding of the habitat considerations they need, whether it's soil or maybe some other element that we don't understand yet. Because we actually do have a fair amount of specialists on black-eyed Susan, and some of them are very rare. Why is that? We don't really understand. We have a specialist on bee balm that is very rare. We don't understand why, because that's one people plant in their yards a lot. So what is the reason why it's so much more rare than its host? These are elements that we're still trying to study. We don't, just because a species is rare, that doesn't mean it's declining. It might always be rare. So trying to separate that is difficult. That being said, a lot of the resources I provided on the handouts, a lot of those links do go to projects in our region that try to track and compile these more interesting species, help people figure out how to spot them and submit observations of them. Yeah, I would check out like the Vermont Wild Bee Survey is a big one. It's applicable to New York as well. Yeah, there are more and more special researchers working on plant lists specifically to help specialists. One of the PDFs that is linked on the handout is from Cornell, from the Danforth lab, and they made a whole guide on how to make a garden for specialist bees with a plant list and everything. So I think they're the only ones who've ever done that. And that's something that is great. We want to see more of that. But a lot of it comes down to we're trying to do more research on these species as quickly as possible. And there's good news, there's bad news. Some species we haven't seen in many decades. We don't know if they're still around. Some species we know are extirpated from New York, especially some of those cuckoo bees, they're gone. On the other hand, we're rediscovering species that we thought were lost from the state. So ramping up survey efforts in a more standardized way to cover parts of the state that are not well represented will yield new species. And a lot of that does rely on regular people just tracking what's in their yard or going out to their local natural area. There's not enough researchers to go around to check everywhere. So a lot of these species either aren't as rare as we think they are, or maybe they are rare and declining, and we need to know where they are so we can protect those places. So there are certainly a lot of people working on it, but we can always use more pairs of eyes.
Yeah.